Hello there, Coach Reza. My name is Owen Beatty, student number 101379668, and this is my video submission for the final of the 4 assignments that we have for our data science class. So let's just jump right into the code. First, as always, we have my student information at the top, and then all of my import statements. Then we jump right into the step-by-step process. So our first step will be to read the CSV and then print out the head, the first three. Then in number 3, we will be dropping the model column, but only in this one print. We don't want to drop it yet until step 4. We can see it's gone here, but it still does exist. And then in step 4, we will be dropping it with a reassignment modifier. So I have it in an if statement just so that I can rerun this cell no matter how many times I want, and it won't throw an error. And we can see that the model column is completely gone. Number 5, we will be dropping the the ID 20, 50, or 20, 40, and 60, which would be 1, 3 of the rows 1, 3, and 5. So as we can see, we have 10, and then skip over to 30 when we print the first 4 heads. 10, 30, 50, 70. In our 6th, we will be checking the mean of the range column, which evaluates out to 297. In number 7, we will be looking for the number of rows which have type F, which turns out to be 50. We will then replace all of those F types with AAAs, and then print out the first 5 rows with this change. So as you can see, ID 10 used to have type F, and so did 70, but now they have AAA. Number 8, we will be checking the type of cost first. I edited this one a little bit myself just to kind of see the whole process between 8 and 9. So first here, we check the data. I check the data type, which turns out to be an object because of all this formatting that we have, and then we remove all that formatting. So we take out the opening and closing brackets as well as the $sign. Then print it, and I checked the data type again because I kind of expected it to be an int at that point. But when I read 9, we see that that's when we actually change it to numeric. It doesn't do it on its own. So we can see that we change it to an int64, and that will come into play later with some evaluations that we do. Number 10, we will be calculating the average cost of the cost column, which evaluates out to 54. And then we check that by continent, which the most expensive that we find is actually from Africa, and the least would be South America. Then in number 11, we will be calculating the min-max and standard deviation, grouped by each continent for the cost column. So there it is. I actually really liked number 11 and 12, evaluating all of these different columns together in one, or from the same column, but evaluating all these different values grouped by continent was actually really fun to just do in a single line. And then once again, 12 is very similar. It did say to work on all numeric columns, which I didn't know whether for this one to include ID. I did for this one purely because I think the purpose of this specific cell 12, was to find information based on the columns, and specifically for just looking at this information at a pure numerical standpoint. It's actually possibly kind of important to understand, like, for example, we know that the first order was from Asia, and we wouldn't do that if we weren't evaluating on the ID columns. Normally, I don't think we would do this, but I think, at least in this cell, there's reason to include ID. And we can also see, I'm pretty sure that the last one is 9,500. And we can see that's from South America, so we actually do glean some useful information from having the min and max of the ID column here. So I decided to include it. In number 13, I did not do that because the IDs were like setting the y axis to be like multiple thousands, so it made all the other information completely unreadable. So I omitted that from the bar graph, but not from the one previously. But yeah, so moving on to 13, like I said, I actually added a comment about that. But we can see some pretty interesting data from the means of the numerical columns by continent. We can see range is pretty high and kind of makes the other two columns unreadable, but not to the same extent as ID did. Number 14, we will check the number of records by continent using value counts, which I like this function. We can see that North America and Africa are tied, with Antarctica having the least, North America and Africa being tied for the most. And then we can see the percent amount of records by continent, so we just use this, the same function, but we normalize equals true and multiply by 100 to actually get the value. We can see that North America and Africa take up 30% when combined, and Antarctica only has 12% of the total records. 16, we will display each unique content value once, and then show the non-unique values, the numerical count, with using unique and n-unique. So you can see just all the continent names that we've seen before, and then the numerical count of them. Then in 17, we check how many rows have a certain value in the cost column. So for the example, the first row here, we can see that there are 20 total rows with a value of 56. And that's tied with 35, also, again, with 20 records. Number 18, we will be plotting a histogram for the cost column. I actually used the same formatting that I found from, I believe it was assignment, it was 1 or 2. I think it was 1. But yeah, I had fun just plotting the histogram with the same color in red and edge color black. I really like all the different ways that you can display this data, kind of like how we have all these different colors up here as well. So there's the histogram. And then 19 is just, it's a bonus with 50 total bins, which makes this data much more readable. It would actually be, it's kind of hard to read just because of, it's hard to look at. You can glean a lot more information, but it is harder to look at than the previous one. It would actually make more sense to even increase the amount of bins, because I think that it steps, each of these bins is a step of like 2.2 amount, which is kind of hard to understand, so I would want to actually increase the amount of bins further in another one, but for specifically 19 asks for 50 bins, so I decided not to do that. Then number 20, we will be printing how many missing values are in the zip code column, in the type column, and then showing a summary of those, so we can see 9 and 2, and that'll come back in a moment. We can see that in the summary, no other column is missing a value, only these 2 in type and these 9 in zip code. In 21, we will be dropping the rows that have any missing values. So we can see that when we do that, we go from having 247 down to having, 947 down to having 936, which makes sense. It actually tells us that all of these, there was no overlap in the null values. Because, for example, we could have only dropped 9 if the rows that also missed zip codes had the type missing as well. But, as we can see, because we dropped specifically 11, that was not the case. Number 22, we will be showing the statistics for the type column using the value count method. We will include NaN and see how many values we have. So as we can see, when we changed F to AAA, that was actually the most populated type, followed by N, and then we can see that we only had 2 NaNs. 23, we will replace those missing values with XXX. And as we can see, we just replaced those two. Number 24, we will be dropping the rows with missing values permanently, unlike we did up here, where we just checked the shape. Here, and if we were to drop them, what the shape would be. Right here, we will actually drop them, and then check the shape again. And since we have changed those NaN values to XXX, we actually remove those two lost ones, so we can see that we only dropped the 9 missing zip codes. Next, we will be running 25. So we'll replace the index with the ID column, and once again an if statement just so that I can rerun this if I wanted to. Then show the first 5, so as we can see there's no more ID column and the values from them have turned into the index. And then we check the value at index 70, which evaluates to 24, which makes sense because it's right there. 26, we will be showing the index, the columns, and the shape of the current data frame, and then returning the ID column. So I have another if statement just for that. We can see, it's kind of messy, but this is, it was requested. Though there's all the indexes, the column titles, once it's brought back, I believe. No, sorry. This will be before. So this is the index column, then the column, then all of the columns, and the shape, and then once we've reset it, how it's changed, back to back to having the ID column. 27. We will be using the describe method to see the statistics and fetch the value of the first row and the third column of the result. So right here, the first row and third column, so we will pull 938, and there's just the describe function in general. Number 28, we will be using value counts of the continent column, and then sorting that based on alphabetical instead of numerical. So we go from having North America and Australia at the top to having Africa because it's alphabetically sorted. Number 9, we will be showing all of the columns from rows 1, 3, 5, and 7, and then showing the first 7 rows with continent, so we can just, there's all that. And then number 30, we will be showing the value and type of the columns, the value of the rows which have type XXX that we change later, and as we can see, we only have those 2 values once again. So that's it. On to the final assignment. Thank you very much, Coach. Have a great day.